Lesson 2. Polynomials, Quadratics, and Progressions. Let's explore polynomials and sequences. If you need to find the remainder when a polynomial is divided by a linear term, like x minus 2, you do not need to use long division. Thanks to the remainder theorem, you only need to evaluate the polynomial at the root of the divisor, which in this case is 2. Moving to quadratics, you can find the sum of cubes of two roots, alpha and beta, without solving for the roots directly. Instead, use the relationships between roots and coefficients. The sum of the roots and their product can be used to find alpha squared plus beta squared, which then helps you find the sum of their cubes. Additionally, you can determine the nature of a quadratic's roots using the discriminant. A negative discriminant indicates that the roots are non-real, and since the coefficients are real, these roots will always occur as a complex conjugate pair. Finally, let's discuss progressions. For an arithmetic progression, the sum of the first n terms relies on the first term and the common difference. Alternatively, if you know the first and last terms, you just multiply n over 2 by the sum of those two terms. For a geometric progression, the sum involves the first term and the common ratio, which allows you to find totals without adding every individual term.